Hey guys, in today's video we're going to look at analyzing polynomials from a graph. We are going to go over odd versus even shape. They do have different shapes as we will see. And if you have a positive or negative leading coefficient, what does that do to your shape? As well as if you have an even polynomial but an even polynomial but a negative leading coefficient, or an odd polynomial but a positive leading coefficient, what do your shapes look like? And then we're going to talk about how to find x-intercepts, zeros, y-intercepts, end behavior, interval of increasing, interval of decreasing, interval of positive, and interval of negative. So here we go. So on the screen right now I have what looks like polynomial soup. You can see all of my polynomials here to the left. I'm not going to trigger all of these at the same time anymore. It looks kind of cool, so I like it. So let's take off. So let's look at all of our even positive polynomials. So when I say even polynomials, I mean the leading power is an even power, like an x to the squared, an x to the fourth, an x to the sixth, x to the eighth, x to the 10th, and so on. So if we look at our shapes here, and I think I'll get a little pink. So if we look at our shapes here, the general, and this is an even, this is a positive even polynomial. So if we look at a positive even polynomial, we see that its general shape, it kind of, no matter what, makes a U-like shape. So it just kind of like ends up in a U, even though there's some kind of bumps in here. So an even positive polynomial is going to look kind of like a happy face, okay? No matter what, all signs go to positive. So that's an even. Now let's maybe look at some even negatives. So I've now triggered the even negatives. So a negative even, I don't know why I wrote so crooked over there. Negative even, I do know how to write, I promise. So a negative even, so no matter what, even though it may have some bumps, it will always eventually take the shape of a kind of frowny face, or upside down, or a concave down. Even this guy to the fourth, it goes up, goes down, goes up, but ultimately goes back down. Okay, so positive evens concave up, negative evens concave down, and some of them may have some bumps here in the middle, but ultimately all roads go to negative here. So that's positive and negative even. Now let's look at positive odd. So there's an x cubed and an x to the fifth. So let me move our graph around if you can see. So that goes all on the right side. That's going to go all the way up to infinity. And if we kind of move our graph down, we'll see it's coming up from negative infinity and it's going up to positive infinity. Okay, and the x to the third graph is purple and the x to the fifth graph is blue. So if we look at this, this is a positive odd. So the general shape for a positive odd, it's going to start down at negative infinity. It's going to take some bumps in here, and then it's going to go up. So however many bumps happen in the center here, same thing with the evens. There may be some bumps in here, depending on the power, but ultimately the shape is going to be the same. For positive odds, ultimately we're going to come from down, we're going to wiggle around here a little bit, but then we're going to go off to infinity. Okay, which is different from if we look at the negative odds. So here's a negative cubic. We can see it goes in the opposite direction. It comes down, takes a little bump, and then keeps going down. And same thing with the negative to the fifth power. Okay, if we follow this, it's coming down, it's bumpy, 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 and then ultimately keep going down. So the shape, so a negative odd starts from up here, does whatever bumps it's going to do, but then ultimately goes down. So it comes from the left, it descends, it bumps a little bit, and then it keeps descending here. Okay, and so keep these shapes in mind because we're going to talk about end behavior. In other words, what's going to happen when we go all the way out to negative infinity or positive infinity. And the sign of the leading coefficient, as well as whether the power is odd or even, that's going to tell us everything that we need to know about the end behavior. But before we kind of started that, I just wanted to give you guys a sense of, and this is general for all polynomials, if your leading power is even, it's going to be concave up or concave down. And then it's concave down if your leading coefficient is negative, concave up if your leading coefficient is positive. The odds kind of look like this weird disco boogeyman shape, like right where the fingers are going like two opposite directions. Positive goes from left to right, it ascends in the way that you want, right? From left to right, we're getting bigger. Odd is the opposite. From left to right, we're getting smaller. Okay, so keep these in mind. I'm going to erase these and keep going. So now what I want to know, so I'm going to trigger some graphs separately. I'm going to turn them all off right now. No, I want you off. Now what I want to know is I want to know, okay, and we're not going to spend a whole lot of time on this because I know you guys know how to read what an x-intercept is. So where are the x-intercepts here, and how do we write them mostly? If we know the x-intercepts, do we know the zeros? Okay. Can we figure out the y-intercepts? And the y-intercepts and x-intercepts, I know you guys are experts at, so we won't spend a lot of time. What happens as x goes to infinity? Where does the function go? What happens as x goes to negative infinity? And this is called end behavior of the polynomial. What is the interval of increase, and there's going to be a lot of these depending. Interval of increase, put some space right here for now. Interval of decrease, interval of decrease. This is totally where you guys can fast forward. Interval of decrease, and we want to know interval of positive. So where is f of x positive, and where is f of x? I wish I had better tablet writing. This is a lot harder than you think. Where is f of x negative? There we go. Okay, so we're going to answer all these questions with each one of these graphs, and maybe not each one. So we kind of already know these for quadratics, so these two, so I'm going to skip these and go with the higher up polynomials since we've talked about quadratics already before. So let's start with a positive cubic. Okay, let's answer all these questions. Alright, where are the x-intercepts? Well, the x-intercepts are where the graph crosses the x-axis, so those three things are the x-intercepts. Okay, and I'm actually not even going to write these because that's just going to kind of take up time. So negative 0.802, 0, 0.555, 0, and 2.247, 0. Right, those are the x-intercepts. That's where it crosses the x-axis. So therefore the zeros then, this is something kind of new, so the zeros then are going to be the x-coordinates of the x-intercepts. So we're going to have negative 0.802, we're going to have 0.555, and we're going to have 2.247. So the zeros and the x-intercepts are almost the same thing. The zeros of the polynomial mean, hey, if I plug these things in for x, I would get 0, right? So if I plug these things in for x over here, they would equal 0. So I could either plug in that thing, or that thing, and they'd all would give me 0. So there's 3 zeros of this polynomial. Notice the pattern. It's a third power, and there's 3 zeros. That's going to mean something significant. Okay, the y-intercept, which I could also trigger, it's right here. It's 0, 1. So the y-intercept is 0, 1. Again, this is just from inspection. Why is it 0, 1? If we plug in 0 for x, 0, 0, 0, oh, we'd be left with 1. Cool. Alright, end behavior. So what happens as x goes to infinity basically means where does this graph go as we go to the right? Where does it go? Oh, it's going to go to positive infinity. So as x goes to infinity, f of x, or the function, also goes to infinity. Okay, when x goes to negative infinity, that just means, okay, now read the graph to the left. Gosh, I could be so much better at these arrows. There we go. So as we read the graph to the left, where is it going? Oh, the function will go to negative infinity. And we're looking at the range here. F of x will go to negative infinity. What are the intervals of increasing? Okay, well, it looks like I'm going to trigger my maxes and my mins. There's a max, there's a min. So it looks like we're increasing from negative infinity to here, which is negative 0.215. We are then decreasing, so we're no longer increasing, and then once we get here, then we start increasing again. So union 1.549, comma, and then from here it looks like we increase all the way to infinity. And remember, the intervals, we always care about the x-axis. Okay, so we have that. Okay, that's the interval of increasing. So now let's check interval of decreasing. Okay, interval of decreasing. I want to know where is it that I'm going down. Well, I'm going up here and I'm going up here. The only interval I'm going down is between that dot and that dot. So the interval of decreasing is going to be from negative 0.215 to 1.549. Okay, from there to there, we're decreasing. Okay, where is f of x positive? Just means, let me erase this and this. So where is f of x positive means where is the function above the x-axis? Well, it's above here and it's above here. Okay, just literally where is it above the x-axis? That means it's positive. Okay, so where is it positive? Well, it's positive here, and that's going to be the point. Let me trigger that. So from here up, it's positive, and between these 2 points is positive. So interval, or sorry, where is f of x positive? Well, it's positive from here to here, so that's point, and remember, it's the x coordinate, 0.802, to here, which is 0.555. So it's positive there, and it's positive from 2.247 to infinity, because it's positive the rest of the way. And that's a 7, not a parenthesis. Okay, and then we want to know where is it negative. So where is it negative is simply just the opposite, is where is this thing actually below the x-axis, which is here and then here all the way down. So let's see, we're below the x-axis. Let me trigger some points. From negative infinity up until that point, and then we're also below between that point and that point. So written out in interval notation. So we're below the x-axis when we come in from negative infinity until we reach this point, which is negative 0.802. Okay, and then we're negative again between these 2 points, which is 0.555, till I get to that point, which is 2.247. 2.247. Okay. Alright, I'm going to pause the video here. If this is enough for you, that's great. If it's not enough for you, I'm going to put in a second video with alternate examples. So again, if this was enough to you and you're good to go and you can analyze polynomials from graphs just from what we've got here, that's awesome. Continue on. If not, come with me to the second video and I'm going to do some more examples.